Hello everyone. In this lab, we are going to learn about mud weight control, and assessment of drilling fluid solid contents. In particular, we are going to introduce the concept of drilling fluid weight control, investigate the effect of barite on the rheological properties of water-based drilling fluids, and determine the solid content of the drilling fluid using the API retort test. Some of the most important functions of the drilling fluid are to control formation pressure and to maintain the borehole stability. Controlling formation pressure while drilling into the well bore is accomplished by adjusting the specific gravity of the drilling fluid so the pressure gradient of the drilling fluid within the well bore exceeds the pressure gradient of the fluid in the formation. The specific gravity of the drilling fluid is increased by adding solids to the drilling fluid. The rheology of drilling fluid must be such that the solids will be held in suspension. For example, suspend barite under static and dynamic conditions. This figure shows the static pressure of importance in well control. These are mud hydrostatic pressure, formation pressure, and fracture pressure. In order to control the formation pressure while drilling, the pressure of the fluid in the well should be greater than the pressure of the fluid in the formation. The borehole wall is supported by making sure the well fluid pressure is greater than the borehole collapse pressure. In order to avoid lost circulation, the pressure of the well fluid should be less than the pressure which would fracture the formation. There are some adverse effects when you increase the drilling fluid density. First, the drilling rate decreases as the mud weight increases. Secondly, the risk of formation damage increases as the mud weight increases. Lastly, the risk of differential pipe sticking increases as the mud weight increases. As shown by the data presented in this graph, as the difference between the drilling fluid pressure and formation pressure, called differential pressure, increases, the drilling rate decreases. This figure shows the mechanisms of a differentially stuck pipe. As the differential pressure increases, it will create a net side force pushing the pipe against a permeable rock, and as a result, the drill pipe will be stuck. This figure shows the mechanism of formation damage. As we drill in overbalanced conditions, in other words, in positive differential pressure, drilling fluid filtrate would invade the reservoir rock and induce formation damage, in other words, reducing permeability. In order to increase the mud weight, we normally use high-density solids such as barite, iron oxide, galena, or calcium carbonate. We can also use soluble materials such as sodium chloride, calcium chloride, and calcium bromide. Some important things to consider while controlling the mud weight is that the surface area of the solids being added to the drilling fluid has a major effect on the drilling fluid's viscosity. Consequently, when increasing the specific gravity of the drilling fluid, the denser the solids added, the smaller the rheology change observed. For this reason, barite, with a specific gravity of 4.2, is preferred to increase the specific gravity of drilling fluid instead of the drill cuttings, with a specific gravity of 2.65. There are two devices that are used to measure mud weight: a mud balance and a true weight cup, also known as a pressurized mud balance. Some common units that are used for drilling fluid density are pounds per gallon, pounds per feet cubed, and kilograms per meter cubed. Hydrostatic pressure can be measured in either psi or atmospheres. Some important things to remember about mud weight that you should know for this lab are: mud that contains barite is referred to as weighted mud, and mud that does not contain barite is referred to as low weight mud. To determine the solids content of weighted mud, a retort analysis is always required, unless no solids are present, which is seldom the case. The solids content of low-weight mud can be determined directly from the mud weight without using a mud retort, provided there is no oil in the mud system. In Figure 1, page 32 of the lab manual, you will find a nomograph that will assist you in determining the percentage of low solids and the percentage of high solids in a weighted mud. With this background information, in the next video we will begin demonstrating the lab. In this video, we have provided the background information for mud weight control and its importance in field drilling operations. Next, we will present the experimental procedure and required data analyses for the lab report.